Now let us study how to integrate the integrals of the form integral of 1 upon x square plus a square. So here, as we know, x is the variable of integration and a is any real constant. Now to solve this type of integral, we again use the substitution method. If you observe closely, the denominator has x square plus a square, that is, there is a positive sign in between. So if we try to recollect which is that trigonometric identity in which we have addition sign, and of course a square relates to a constant term. So therefore what do we do is we substitute x with a tan theta, and the reason will be immediately clear. Now if this is the case, for substitution we need to keep ready dx, so that gives us a, and the derivative of tan theta is sec square theta d theta. Alright, so whenever we substitute these values in our integral, so therefore our given integral becomes 1 upon, now x square will become a square tan square theta, because we had put x as a tan theta, plus a square as it is, right, into dx is nothing but a sec square theta d theta, right. So that gives us 1 upon, we can definitely cancel out a from the numerator as well as the denominator, and in the denominator we will have a common, and what remains in the bracket is tan square theta plus 1 d theta. Now we know that tan square theta plus 1 is sec square theta, so that will also get cancelled, and we are left with 1 upon a integral of d theta. So integral of d theta is nothing but just theta, and of course plus c. So that gives us 1 upon a. Now we must replace back theta in terms of x, because theta is the variable that we had introduced on our own. So if we look at what we had substituted originally, that is x equal to a tan theta, so you know that means x by a has to be equal to tan theta. So therefore that implies theta is equal to tan inverse of x by a. So therefore we substitute at the end, and we have 1 upon a tan inverse of x by a plus c. So that's the answer for the integrals of the form 1 upon x square plus a square. So to remember this form, what we have to really understand is that it is having a variable term square plus some constant square. Alright, now let's go ahead and see the other variety, that is the integrals of the form 1 upon x square minus a square, or 1 upon a square minus x square. So it is almost similar to the previous form that we saw, except the sign in the denominator is negative. So therefore it gives rise to two possible combinations, that is x square minus a square or a square minus x square. Now the method for both of them is almost similar. Now let's try to evaluate the first one, right. Now here we have 1 upon x square minus a square dx, that is equal to, now if we observe, we can definitely factorize this into x minus a and x plus a. Now comes the important step. Now this particular fraction can be broken into two parts as 1 upon x minus a minus 1 upon x plus a. But let's see what happens if we just keep this subtraction as it is. When we cross multiply, we will get x plus a minus of x minus a. So no doubt x gets cancelled, but a minus minus a gives us 2a. So it is the term 2a that we are getting by our adjustment, but in the original integral there is just 1. So it means that 2a is what we are multiplying additionally. So to offset that, we must divide by 2a outside the integral, so that we are not changing the original expression. Right? That's it. The reason for doing this is now apparently clear, because now the two terms can be easily integrated. As we know, the integral of 1 upon linear term in x is nothing but log of that particular linear expression minus log of x plus a plus c. So which in turn gives us, we can merge the both logs, and since there is a subtraction of logs, we will do the division of terms inside the logs. So that is log of x minus a upon x plus a plus c. So that's the final answer of this particular integral. Now in case of the second integral, there will be just slight change, because there will be the other way of representing the given fraction. So again the answer will also be just minutely different than this particular one. So let us recap the last three integrals that we saw. So here is the summary of those results. Integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a plus c. Then integral of 1 upon x square minus a square is 1 upon 2a log of x minus a upon x plus a plus c. And lastly, if we switch the order in the denominator as compared to second integral, it becomes 1 upon a square minus a x square. Then its integral is 1 upon 2a log of a plus x upon a minus x. So you see, these two integrals are almost similar to each other, so they are not difficult to remember.